located in the United States where flax is grown and processed commercially. Climatic conditions of the valley are ideal for the growing of flax. Each year, featured in this parade is the Festival Queen of 1947, followed by Oregon's representative to the Atlantic City Beauty Pageant. Everyone is familiar with linen and its fine qualities, but few have knowledge of the extensive processing required to extract and prepare flax fiber suitable for spinning. We leave this celebration and show you how flax is grown and processed. For best results, flaxseed is planted between February 15th and April 15th on a well-prepared seed bed. The rate of seeding ranges from 60 to 85 pounds per acre. This field of flax is 2 months old. A weed-killing treatment has given the bright green flax a yellow tint. Chemical spraying of flax for weed control has practically replaced costly and laborious hand weeding. Commercial fertilizer is usually added to the spraying liquid to supply nitrogen for the early spring growth. In early morning, the flax field is a solid blanket of white blossoms, but by noon the plant sheds most of the flowers. Notice the seed balls formed on the branches near the top of the plant. Fiber flax produces an average of 9 bushels of seed per acre here in the valley. Early in the 19th century, many patents were issued on flax pulling machines. The modern pullers are a development of the last 30 years. These Sonnen pullers were developed in Belgium and introduced into this country in 1939 by the United States Department of Agriculture. Notice how the bundles cling together, causing a loss of seed and damage to the straw. The pulling starts in mid-July and lasts until mid-August, depending on the season and date of planting. Prior to the development of these machines, flax was pulled by hand, as much of it is pulled today in Europe. 68 man-hours per ton were required to hand pull, as compared to 2 man-hours per ton to pull with a machine. This is a Willamette puller, developed here in Oregon. It is simple, fast, and is rapidly gaining popularity. The machine pulls over an acre an hour. For best quality fiber, flax is pulled before the straw and seed are entirely ripe. The bundles are shocked in the field, allowing the straw to cure and the seed to ripen. It is not economical to haul flax straw a long distance because of the small quantity of fiber and seed in a ton of straw. This is the first of at least 10 times that the bundles are handled by pitchfork. Are in operation 8 private and processing mills. This is the Clackamas County plant at Canby, Oregon. Here are drying fields, the storage sheds, and various processing buildings. The seeded flax enters the plant by way of the office and scales. During harvest time, it is not unusual to see several loads of flax waiting to be weighed. Unloading and stacking are other pitchfork operations. A majority of the plants now use mechanical conveyors to replace several men. Notice how handling with the pitchfork pulls straw out of the bundle. The de-seeding operation is the mechanical separation of the seed balls from the flax straw. A part of the crop goes directly to the de-seeders, and the balance is stored for later processing. This is the whipper roll de-seeder. The operator is spreading the seed ends of the bundle and passing the straw between the rollers. The rollers crush the seed balls and liberate the seed. This This machine will process 1 ton of flax straw per hour and requires 10 man-hours per ton of straw processed. Prior to the development of a better machine by the Cooperative Research Project, the whipper was used throughout the industry. The operator is butting the root ends, keeping the individual straws parallel. This facilitates handling in later operations and results in higher yields and more even fiber bundles. 2 strings are placed on each bundle of straw. One of the first undertakings of the research project was to develop a machine to eliminate as many men as possible in the de-seeding operation. A Rotcombe-type deseeder was developed and has practically replaced the whipper-type machine throughout the industry. The latest de-seeder development is this machine, which has made possible a straight-line operation. Incorporated in it is an inclined feed table, a mechanical butting arrangement, and a double needle binder. The machine is stopped so that the combs can be observed entering the layer of flax. This machine will de-seed 2 tons per hour and requires approximately 2.5 man-hours per ton of straw as compared to 10 man-hours per ton for the old type. The seed balls removed by the de-seeder are conveyed to a conventional threshing machine where the seed is separated, cleaned, and sacked. To this earlier model of the rotary comb de-seeder has been recently added an experimental device which automatically divides the layers of straw, assisting the double needle binder to form bundles of equal size. This unit has operated 1 year under commercial conditions at the Mount Angel flax plant, doing the work of 2 men. This machine, when used with straw butting and conveying equipment, will further reduce the labor requirements of the de-seeding process. This load of flax is being taken from the de-seeding building to the retting tank by way of the scales. The de-seeded straw, in excess of that which can be retted, is stored in the large sheds. Flax retting is performed during the dry summer months so that the wet bundles can be dried in the field. This is a battery of retting tanks into which the de-seeded straw is placed. The straw is soaked in warm water from 3 to 7 days, where the bacterial action loosens the fiber from the remainder of the straw. The filled tanks of straw are covered with wooden grates. These grates are held down by the heavy timbers, manually placed in position. The retting appears simple, but in reality, it is the most tedious operation of flax processing. The inherent good quality of flax fiber is either preserved or destroyed in the retting process. Industry still depends upon a physical examination of the straw to determine the time to stop the ret. The accuracy of this depends upon the experience and skill of the operator. The retting water is heated by a steam boiler utilizing flax waste products as fuel. Uncapping consists of removing the heavy timbers and wooden grates. This work is hazardous as the workers carry heavy loads while walking on the slick grates which lie unevenly on the retted flax. Every inch of the tank is filled in order to process as many tons as possible during the dry summer months. Notice that the grates, spacers, and timbers have been bolted together and are being moved as a unit with overhead trolleys and chain hoists, whereas in former scenes they were removed by hand. This method of capping reduced the physical efforts and requires 5 minutes per operation as compared to 30 minutes by the old method. The removal of the lid is referred to in the industry as uncapping. The use of this device not only reduces the man-hours, but also eliminates the damage to the flax straw caused by the workers walking on the wet, tender flax. Now, the wet bundles are removed from the tank and placed on a truck, which will carry them to the drying field. The tank is washed before filling it with a new batch of flax. The retted flax is unloaded at the drying field. The bundles are set up in the form of a wigwam and allowed to dry from 5 to 10 days, depending on the weather. The retting season begins when the spring rains cease and ends when the fall rains begin. Considerable skill is required to form satisfactory wigwams. The plants use from 15 to 20 acres of ground as drying fields. The dried wigwams of flax are then removed and bound with a portable binder. Three men and a tractor are used in loading and hauling the flax from the field to the storage shed. This machine is an experimental self-propelled field binder and loader. It has been tested under commercial conditions and has been found to have a larger capacity than the binder previously shown. A single man places the bundles on the load, releasing two men and a tractor for other duties. Flax is hauled to the storage shed by way of the scales. It is customary to ret a sufficient volume of straw during the dry summer months to supply the scutching machine during the remainder of the year. Scutching is the breaking and beating of the straw so that the woody parts are separated from the fiber. A load of flax on its way to the scutching building. This is an experimental feed table that conveys, butts, and feeds straw into the scutcher. The scutcher is a Van Howert machine located at the Washington County Flax Plant, one of the two types used in Oregon. The straw passes between fluted rollers which break the woody core into small pieces. The commercial scutchers all use this type of breaker. A disadvantage of this type of breaker is that it leaves approximately 6 inches near the center of the straw unbroken. The scutcher has two beating sections. The gripping device holds the straw while the first section cleans the free end. In the second section, the fiber is gripped while the other end of the straw is cleaned. At the discharge end of the machine, the cleaned fiber is gathered into bundles called hanks. Here, some sorting of the fiber is done according to length and degree of cleanliness. The short fiber and woody material is collected and passed over a device to shake the loose stem material out of the tangled mass of fiber. The product is called flax tow. This experimental bucket-type butter was used in conjunction with this scutching machine at the Benton County Flax Plant to even the root ends of the straw. This enables the scutching machine to discharge fiber more evenly and raises the line fiber yield. The scutcher feed table shown is of the conventional type, where the straw is spread, butted, conveyed, and fed into the machine by hand. The experimental inclined feed table shown in connection with the previous scene does a more efficient job and requires 2 less people for its operation. This experimental scutcher has several improved features, enabling it to extract from 10 to 20% more fiber from the retted straw. These features are an improved gripping device, a rotary breaker, a shorter fiber transfer, and a combination downdraft, dust, and tow removal system. inspection doors of this machine are open to permit observation of the breaking and scutching operation. The fiber is removed in the same manner as with the conventional machine. The girls are hanking and sorting the fiber. This is an experimental tow dryer and cleaner located directly below the scutcher. The separator box removes the tow and unbroken straw from the dust-laden air stream. The loose woody core or shive is removed from the tow. The downdraft dust elimination system removes dust which otherwise would cause a fire hazard and contribute to the discomfort of the workers. In this plant, tow is baled in a conventional hay baler. It is now ready for shipment to the tow spinner. Here is the Oregon flax textile plant located at Salem, Oregon. Broken bales of tow are fed into thin layers by this machine. The machine breaks up the bales of tow, feeding the converted wool card with a thin layer of fiber. The spreader evenly distributes the thin layer into a mat. The mat is again carded, where the ribbons of fiber are placed in cans. The spinning machine removes the sliver, twisting it into a yarn. The yarn is dyed on the spools. The yarn is spun into a rug on this 12-foot loom. This is a woven jade green linen rug. Here, a braiding machine twists several colors of yarn into a multicolored braid. These colorful rugs will be used to brighten many American homes. Scutcher fiber is hand-hackled, graded, and bundled prior to shipment to the spinning mills. And now to the Salem linen mills. Bales of flax line fiber. The hanks of fiber are placed in the holding plates of the hackling machine. As the fiber is moved, it is subjected in graduated steps from coarse to fine pin combs. A drawing frame is connected and timed with this machine so that it discharges a continuous sliver or ribbon of flax. The slivers are then spun into yarn on roving machines. These yarns are now ready for weaving and industrial uses. Oregon linen yarns are used to weave specialty items for the home, such as tablecloths, napkins, table mats, hand towels, and other household linens. It is used in the manufacture of fishnets, fire hose, shoe thread, sewing twine, casting lines, marine packing, toweling, and many other industrial products where strength and durability are required.